Good evening, sir. This is Mahijendra from IT section A, sixth semester. So today my topic is a priori algorithm. So with a quick growth in e-commerce applications, there is accumulation vast quantity of data in months, not in years. Data mining are also known as the knowledge discovery in databases to find anomalies, correlations, and patterns, and trends to predict outcomes. So, a priori algorithm is a classical algorithm in data mining. It is used for mining frequent item sets and relevant association rules. It is devised to operate on database containing a lot of transactions. For instance, items brought by customers in store, and it is very important for effective market-based basket analysis, and it helps the customers in purchasing their items with more ease and which increases the sales of the markets too. It has also been used in the field of healthcare for detection of adverse drug reactions, and it produces association rules with indicates with all the combinations of medications uh, and patient characteristics. Uh, so Here, basically to select interesting rules from the set of all possible rules, constraints on various measures of significance and interest can be used. To best known constants are minimum thresholds on support and confidence. So basically, the support here is support of an item is set X can be defined as proportion of transactions in the data set which contain the item set, and support X is number of asset. Confidence is the confidence of a rule is defined as mm, is a formula support of X union Y and by support of X. So the a priori algorithm is an influential algorithm for mining frequent item sets from Boolean association rules. And a priori algorithm is a bottom-up approach where frequent subsets are extended one item at a time. Set up as a candidate generation of group of candidates are tested against the data, and this algorithm is designed to operate on database containing transactions, for example collections of items brought by customers or details of a website frequentation. So here's a key concept: frequent item sets. So basically the frequent item sets, all the sets. So here basically frequent item sets, all the sets which contain the items with minimum support, denoted as far from the set. A priori properties, a priori property. Any subject of frequent item set must be frequent. Join operation to find a set of candidate k items sets is generated by joining with itself. So let's go. Here the goal is given that set of transactions T. The goal of association rule mining is to find all the rules having the support which is greater than or equal to minus support threshold and confidence greater than or equal to minimum confidence threshold. Here's the approach is brute force approach. Uh, oh, sorry. Uh, with all the list all the possible association rules, compute all support and confidence for each rule, prune rules that fail to minimum support and minimum confidence thresholds. And let's go with the steps. So let's go with all the steps of algorithm here. Basically, so here's the example: is a problem decomposition. Uh, Basically, scan the transaction data based on the get support S in each item set and compare S with a minimum support and get a support of one items. Use a join to generate a set of candidate K. Use a priori property to prune the unfrequented K item set from the set. and scan the transaction database to get the support S of each candidate K term. Set the given set compared to S with the minimum support and get a set of frequent K item set. So if the candidate set is null for each frequent set one, generate all the non-empty subsets of one, and for every non-empty subsets of one, output the rule S tends to 1 S per n if confidence of C is the rule. And here S tends to 1 minus S, that's minimum confidence. If the candidate is set to null, go to step 2. So here basically this 4 transactions, and with the items bought, and we have a different kind of items in the database here. And if the minimum support is 50%, and the shoe so basically we have to find the frequency of each and every object in the database. So let's start with the table step 1. Let's start with the first object, shoes, and which has occurred 3 times in the whole table, and which is also divided by 4. So 3 by 4 is basically 75%, and which is greater than 50%. So we'll be considering the object shoes, and we have to calculate this frequency and the support percentage for each and every object in the table, and we have to discard the support or we have to discard the object which has support less than 50% here. And if the minimum confidence is 50%, then only 2 rules generated from the 2 items that have confidence greater than 50% are shoes, jacket support 50%, confidence is 60%, 66%, jacket shoes is support 50%, and confidence 100%. So, so let's go into another example here. Uh, as I said, we have to find the frequency of each and every object in the database. So let's go with one. One has occurred 2 times. If the support is 2, that's 50%, and the support for object 2 is 75%. And let's go with the object 4 here, and it's only 25%, because it has only occurred 1 time in the object in the transaction ID 100. So it's 25%, which is less than 50%. So we'll be discarding the object 4. I have to keep on moving forward with this step, and we have to pair up. And after discarding all the objects which has less support than 50%, so we have to so let's we have to move to the step 2, and whereas in which step 2 we have to pair up the objects, like as shown here, 1 and 3, 2, 3, 2 and 5, and we have to move forward with the same process as we have done in the step 1. We have to discard the support which has less than 25%, 50%. So here object 1, 2 and 1, 5 are discarded item set, and uh, sorry. So by doing this, we are left with items at 2, 3, and 5, which are 50% minimum support. So a priori algorithm is basically let k is equal to 1 in generate frequent item sets. Repeat until no new frequent item sets are identified. In this step, generate length k plus 1 candidates item sets. Uh, so count the support of each candidate by scanning the database. Eliminate the candidates that are frequent, leaving only those are the frequent. Uh, this is basically the algorithm. So let's take a look about it. CK is candidate item sets of size K, and LK is frequent of item sets of size K. And as I mentioned, all the steps in starting. As I said here, when the step 4 occurs, if the confidence is not null, we have to move to the step 2, and if it's null, move to the step 5. And basically, let's go with advantages and disadvantages. large item set property, easily parallelized, easy to implement, uh, assumes transactions database in memory resident, requires many database scans, and it requires also more time. Uh, summary Summary of the algorithm. The algorithm is an efficient algorithm for finding all the frequent item sets and although the association rule. And the algorithm implements level-wise search using frequent item property. The algorithm can be additionally optimized. There are many measures for the association rules too. So here I'm done explaining, and we are done understanding the a priori algorithm here. So let's take a leave. Thank you.